Elon Musk is a polarizing name. If you hear him, you're either thinking, wow, he's a great, cool guy, he's an interesting guy, or you're thinking, oh, I don't like him at all. And he's come out with a lot of stuff that people don't agree with in the past. But if there's one thing that Musk knows about, it's bringing innovative new products to market. The Teslas, I mean, we don't have to go far to look at very innovative manufacturing processes and indeed designs. Look at the Cybertruck, for example. And then you've got SpaceX. SpaceX, a private company, yet in partnership with NASA, it's become so important in the space exploration world. And he's really pushing the boundaries with rocket technology and other elements of that. There was a video recently where he was interviewed about his steps to bringing new products to market. And there was a lot of crossover between what Elon Musk has learnt and the structured NPI process that we follow at Sofeast. So Renaud's going to go through what Musk's comments are and talk about how we can learn from Elon Musk's NPI insights ourselves. You're listening to China Manufacturing Decoded from the Sofeast Group. Hello, Adrian here from Sofeast. Renaud joins me today. Hi.
Hey, hi Adrian.
Hello. It's episode 221, Renaud, and we are covering today Elon Musk, a fascinating fellow. Some people really love him, some people hate him, but like we
Yeah,
say in the UK, it's kind of like Marmite. If you've heard of Marmite, it's a kind of love-hate thing with Elon Musk.
right. Yeah, so he came actually, I think this video came out a while ago. I'm not too sure.
Yeah, 2021,
Um,
I think.
okay, that's why I think I saw it before, but then we were looking at it and we say, yeah, you know what? That's just another way of saying what we keep saying. So that's
Mm.
interesting because okay, so for people who don't know, okay, Elon Musk, was one of the founders of one of the companies that became, what the PayPal that we know today, got a lot of money,
Mhm.
reinvested it in a new rocket company. At the time, everybody thought it was crazy, but he really likes sort of hardcore physics problems, it seems. And he went for something that even Boeing and Lockheed Martin and so on didn't even try, or maybe they didn't try for too long. I don't know. Is the reusable rockets that would just come back down to Earth.
Mhm.
At least the first stages, so it can be reused and reused, which makes it much more economical to use. SpaceX has been a huge success, but it's how to say, it's famous for being a place where it's like the special forces. You go there, you're going to work your tail off. You're going to work 60 plus hours a week. You're going to be under pressure. And Elon Musk comes up sometimes like, oh, let's do a surge and it means like, let's get everybody really nervous and let's put a insane deadline and let's get to the next step. And like
Mm.
recently was uh, let's let's push it really hard to get these Merlin whatever rocket engines working and everything. And now they are doing a series of repeated experiments, sending that new huge rocket, much bigger than anything that had been made so far, from what I read. What is it? I forget, the super heavy or something.
Mm.
um, I forget. They have a funny name for it, which I forget. So they keep doing experiments, sending it in, to orbit or nearly in orbit, and getting it back and seeing how all of that works. So SpaceX, yeah, huge success. His other company, obviously, everybody's heard of is Tesla. So same thing. Um, a lot of people there think is sort of nuts. He's come up with some pretty good um, decisions and maybe some not so good ones, like that Cybertruck,
Huh.
right? But he's he's learned, and then there's some other stuff we're not even talk about, like purely software, AI, social networking, and so on, right? Um, But what he's been doing basically is bring entirely new, very innovative products all the way to market, and successful in the market, right? So we're talking about several very different models of rockets that not only are designed sort of from the ground up, um, but also have some features that are new and very innovative. Like, okay, it goes back, it goes back on Earth and can be reused. It's just amazing. Um, the various car models. I mean, when the Model S came out, it was voted as best car in the world, etc., etc. I mean, you know, he can be a great product guy. Okay,
Mm.
maybe not people manager. Not sure he would get any award, or maybe like the most toxic product, people
Yeah.
manager, maybe, right? Definitely not the healthiest one. Okay, but in terms of product development and product management, um, he has outstanding experience, right? It's not just
Mm.
product, it's also manufacturing processes. I mean, a few years ago, he was saying a lot of nonsense, um, when they were going through, what was it, the Model 3 industrialization, and they were like, oh, let's automate as much as we can, or the robots need to be so fast that you can't even see their arms moving, otherwise it's too slow. He was giving this kind of injunctions, direction to his engineers, and some of them must have been thinking, this guy's nuts.
Mm.
And but you know what? Sometimes some people have to learn through trial and error. And this guy has done more trial and error than anybody I know.
Mm. Yeah,
Right?
he's not risk
They,
adverse.
oh, yeah, he has a very high tolerance for risk, let's say this way. Maybe he
Mm.
thrives on risk also in crazy situations. So what is there to learn from him? Well, he has, as I say, done, trial and error. He has, for example, automation. One point it was like, let's automate as much as we can. Why should we have so many people moving things and doing things? Of course,
Mm.
it's more consistent and faster and cheaper. The more it's automated, the better, right? Basically, and we'll fine tune things and we'll learn, and like, let's go full steam ahead. And then he actually went backward. Um, there's some stories in some of the battery, what they call, what is it, mega factories or giga factories? I forget. Anyway,
Hmm. Gigafactory,
um,
I think, right?
yeah, gigafactory. Okay, they like this kind of names. Yeah.
Yeah.
Okay. Anyway, um, and I think, uh, yeah, I forgot the name of the rocket. It's a funny name like that. Um,
The biggest one that they're making at the moment.
yeah,
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 it's the
right,
Super
right, right.
Heavy.
Yeah, super heavy. Okay. But there's something else. I forget. There's
Ah,
oh,
okay.
Starship or something like that, right?
Right.
Yeah, Starship. Okay. So, okay, funny names. What I was saying is that, for example, in one of the battery factories, he invested too much in highly automated equipment that they just couldn't get to work consistently,
Mm.
because you don't go from zero to full automation like that straight. It's extremely risky, right? You go first, you do more, mostly manual work, and then you automate and you automate and you automate. I don't know, you do automated unloading, and you do whatever, faster cycle time, and a bit more operations together, etc., etc. And then you do maybe automated loading, which is often a source of a lot of problems, and so on and so forth. You go step by step, and as you go step by step, first you do it together with the automation supplier, because they should know what they're doing and they should be able to guide you also. In their factory, in your factory, you do several kinds of validation tests, and then you have your maintenance. So you have two types of people who are critical: people who program the equipment and people who maintain the equipment.
Mm.
And if they don't learn themselves over time, through training, but also through experience, how to work with the automated equipment, then you have a huge problem, right? Now, at one point, it's just too automated. It's, I don't know, it's got a cycle time that's, very, very short, and, you have a huge capacity here, but you don't need even 10% of that capacity. Why would you go for that? Sometimes it doesn't make any sense. Okay.
Mm.
So he he ignored all of that wisdom, well-known wisdom, and he went, okay, let's automate, as fast as we can, then we'll be very fast, etc., etc. And then they had to like cut open some huge doors into the walls of the factory to get their
Yeah.
super expensive automated equipment out, and they put humans back on the line to put things together, right?
Yeah.
So they learned the lesson. It's expensive tuition fees, right? But then and that's just an example. So he went through rounds and rounds and rounds of that, and he kind of has his own philosophy. When you develop a new product that is innovative, that is not like anything that's been done before. We cannot just get a lot of inspiration, mostly copy an existing design, change it a little bit. No, no, no. This is an innovative product, a new product, something that was not in the world before. Well, there's a certain order to the steps that you take, right? You have to follow a certain logic, right? And that's what's interesting here, and there's really a lot of parallels with what we keep saying
Mm.
on on this podcast, but also to our customers is, hey, when you develop a new product, you have to go through these phases. You have to go through these phases of the new product introduction process, right? You can't skip any one phase. You can't let's just merge them, do everything in parallel. I mean, most of the time you can't, and you should not.
Mm.
You should not do things backward. You have to go through 1, 2, 3, 4, 5, 6. You can't, jump to 3 and 4 and then back to 2. I mean, that that happens. That's the reality sometimes, but that's because of mistakes. Because if you haven't done a proper feasibility study and assessment of the risks and so on, then yeah, you might do a lot of work and a lot of prototyping work and even go into fabricating tooling, and then you have to go back to to the phase before that, after having invested a lot of time and budget to fix some fundamental issues because there's one technical problem that was not addressed the right way.
So it's funny that when you talk about Elon Musk learning through failing, right? He's basically come to the same conclusion with MPI that we have by going through it so many times over the years.
Right.
And
Yeah.
we'll draw some comparisons between that and, of course, our own. But as you mentioned, we always talk about how important this is. So it's kind of a relief that he is also following that for important things like rocket boosters and things like that.
Right. So it's basically what he says is there's a certain logic. You have to
Mm.
do this before you do that, and so on, right? And he gives like 5 steps, logical steps, one after the other. It's not really like the roadmap to build a new product.
Mhm.
It's more like in terms of the way to think and the sort of priorities that you need to have, in the process of developing a new product. It's not really like, as we say, like first you document the requirements, then you do some kind of feasibility study, do some proofs of concept, then you do some design iterations with prototyping, build, and testing, and so on, and then you fabricate the tooling and do some background work on quality standards, etc. Then you do a pre-production pilot run, then you go into mass production. No, this is not the way he thinks about that.
Mhm.
And by the way, what he says is true both for a car company that does go into high volume production, right? Tesla, but it's also true for a rocket company that will not make high quantity production at all. right? Especially as they reuse the first levels, right? So they will make a bunch of engines, and then these engines, hopefully, they will keep firing like 50 times or 100 times, for a number of takeoffs. Okay, so in SpaceX, they're not talking about mass production or high volume production at all, right? But at Tesla, they are. So his mental framework is actually quite flexible, right? He's very much whatever you design, if it's really new, you're gonna have to follow these different priorities. So let's go through that.
These actually we got from there's a video on YouTube from Everyday Astronaut, and it's quite a long interview with Elon, and part of it is where he talks about this. So we will leave the link to the video in the show notes, and it'll be embedded in the blog post and etc. And you can go watch the video. But that's what you're going to be referring to, right, Renaud? So
Right.
let's kick off with the first one.
The first one is to work on the product requirements, and as he says, to make them less dumb. So every time you have a big project of developing a new product, yeah, you're gonna say, what are the requirements first before we even start to grow anything. So if they say, well, it's gonna be a new kind of rocket that's much bigger because it has to go up with that huge payload, because the objective is to reduce the price per kilogram that we put onto orbit, etc. Or they come up with, okay, let's design a monstrous truck, that's electrically powered, will draw the electricity from batteries and will look like a science fiction kind of truck.
Mm.
Okay, this is like the concept. But then you in these kinds of huge projects, you actually want something like 100 pages or more of requirements, right? Oh, a truck. So what's like the maximum size, and what are the regulations going to to require, and blah blah blah, right? And what's the autonomy, and what's the maximum speed, and what's whatever, the size of the wheels, and so on. And then they start to play with some concept designs, and then they keep refining the requirements. Okay, and the one let's call it sort of it's his mental model, right? So it's the focus. Okay, he gives us 5 different stages of the NPI process where the mental uh, focus needs to switch every time, right? So when you work on the requirements, what he says is make your requirements less dumb. Okay, and what he says is um, have them reviewed, and then make sure that every time there's a requirement coming from somewhere, we know who wrote it down so that we can go and ask that person, right? So
Mm.
if someone, he gives an example from SpaceX, but I don't know if, for example, for a car, if someone from the legal department says, "Oh, the truck should not be too angular, because otherwise it might kill pedestrians," then okay, that's Miss whatever, John Smith. And then when you want to push to have a really crazy design, then you say, no, I want it to be very angular. What is that? Then you go ask John Smith, and John Smith is going to say, well, that's if you want to sell it in certain areas like the EU. And then you say, well, maybe we don't care about the EU. Okay. What about in the US and Canada? It can be angular. Okay. So let's just go crazy and make it very angular. And we don't care if it kills pedestrians,
Mm.
So this is sort of the way to challenge the requirements, right? And as it says, make them less dumb. But this is through reviews and exchanges and so on, right? And does it make sense? Yes, of course. Requirements need to be considered carefully by experienced people, and they need to be discussed in the development team. and they need to be challenged, or at least some of them need to be challenged. Well, why do you want your e-bike to go up to 100 miles an hour? This is just crazy. Oh yeah, right. Sorry, it's a typo. I mean 10 miles an hour. Okay. Right? But sometimes people don't get challenged, and some crazy requirements have a huge impact on cost, on time of development, etc. Right?
Mm.
So basically, the way to write the requirements is quite important. Right? That's his advice for
Mm.
that phase. Well, obviously, nothing to say here. That makes
Yeah.
a lot of sense, right?
Yeah. You can't really argue with that.
Right, right, right. The second one is to delete parts of processes wherever possible and simplify. Actually, before simplifying, he says delete parts of processes, and then he says simplify. But I would actually say this is relatively similar. There's some overlap, and of course, if you simplify, if you come up with a design, I don't know, you want to design a coffee machine, and the coffee machine will, I don't know, will also make tea and whatever. Then you say, well, actually, it's getting a bit too complicated. We're going to remove the tea module. Okay, then we're also going to remove, some parts, right? The separate container, etc., etc. So as you simplify, you remove some parts also. So to me, this is sort of all together at the same time, roughly, where you say, okay, what does this concept design actually entail? What is what does the industrial design look like? What are all the implications of this? Um, what would the technology be? What materials do we need to use, etc.? How does it all work together? Let's do a simple proof of concept, and then also at the same time, obviously, talk to potential customers, right? And see what is super important to them. Yes or no. If it's, if there's like some, yeah, it would be nice to have, and you see that it's going to add 3 to 6 months of development time and $100,000 extra, well, you say, stop it, what is it that the product must have? This is the main feature. It needs to work that way. That's what will really make you there. Okay. So that's what we need to do. Simplify the product, at least in version 1. Don't go crazy, and keep the nice ideas for version 2, right? This is also something we talked about before. If you develop a new hardware product, it's really innovative. You need to think about it in terms of version 1, versions 2, version 3, where you have version 1 is just
Mm.
the must-have, features. It's not going to be perfect, but you will see what the market says. You will iterate, and version 2 will fix the main problems, right? But version 1, the job of version 1 is to consume as little as possible in terms of resources and time so you can get to market. And of course, its job is to sell so that you can survive and get to version 2, right? The job of version 1 is not to be perfect. The job of version 1 is not to always have a 5-star review with every kind of customer. No,
Mm-hmm.
you need to go with niche, markets, and be very specific about what it does, because it's not going to do everything, right? Because if you want something that does everything and pleases everybody, it's going to be so complicated. Maybe it's going to be too expensive for them, but also it's going to take an enormous amount of development time. Okay, so simplify the concept, delete parts, delete processes. There's so many examples of that. If you want, I don't know, you want to develop your own charger that's going to be integrated into the product. Well, you're going to have to get it certified, and that's going to add tens of thousands of dollars of certification costs. Okay,
Mm-hmm.
well, remove that from your product. Just go with buying standard off the shelf kind of chargers that are pre-certified, and you shave off a lot of development work and time, plus a lot of certification fees, right? this is just an example. Okay. And also when you say it says did its parts or processes. So already think of manufacturing. Okay. When you design a product, you already think what the manufacturing and the assembly process will look like. And you need to start to do DFM&A, right? Design for manufacturing and assembly. And I believe we shot a video with Andrew about that a couple of years back. But one of the things that's like among the first ones at the top of the list when you do good design for manufacturing and assembly is, can you remove some parts? Can you combine some parts? So maybe make the manufacturing itself a little bit more complicated, but then you don't need to assemble these parts because they already, combined into only one part. And that kind of fastening method or whatever, is not needed because the sort of, I don't know, cast, in the same mold or whatever, and the whole product is stronger, right? And maybe also the whole product is lighter, has better physical performance, right? There's some other things like, go with standard off the shelf parts rather than custom design parts as much as you can, and things like that, right? All of that plays to the general advice of delete parts of processes and simplify. Okay. He also says you delete parts of processes, you simplify, then you optimize. Okay, so obviously when you do engineering design, you need to keep refining, or optimizing your design, right? You do an iteration, you build a prototype, you see ways that it could be improved, and then you think of what you will need to do, and then you go into another design iteration in your design, and you build prototype and you test, etc., and you keep refining. That's a normal part of the process. However, if you do that before simplifying the process, you keep trying to refine something that's excessively complicated. And you waste a lot of time and a lot of fees, non-recurring engineering fees, right? A lot of time, a lot of money. That is just not the right order. So what he says is first you delete parts of processes, you simplify. Okay, then you can really try to optimize, and you keep trying to simplify when you optimize, right? I think that's the right way to say that. And the way we kind of do this in the new product introduction process is that when you do a proof of concept prototype, when you do a feasibility study, you try to put the finger on what's going to be the source of a lot of complexity, what's going to lead to a lot of difficulties, a lot of risks, and then you kind of challenge the development team. Hey, is this really very, very important? Does it really have to be part of the product, or else, or can you just get rid of it, right? That makes a lot of sense. And you try to think of the high level architecture and keep refining and challenging the requirements. That's why you need to know who came up with the requirements and question them, right? Before you go into the engineering design in the details, refining the designs through iterations, etc., 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 right? And optimizing. Now, first you need to ask a lot of questions before you do that. Okay, that makes a lot of sense. And then once you are sort of going in the right direction, then what he says is like accelerate cycle time. Just go faster. You're not going fast enough. Just go faster. And by that, I kind of agree with that. At the stage of the new product development process, where everything is kind of clear already. Okay, you no longer have a lot of high level questions in your mind. You know the design architecture, you know what direction you need to go. You've already done some of the refinements. Okay, how can you go a bit faster? How can you be more agile? How can you get feedback faster from the users? How can you prototype and test faster? And then also when you go into, okay, let's make some tooling for production. Okay, well, how can we do that faster? What can we do in parallel? Or some of the parts, maybe there's no risk that the design is going to change. Let's make the tooling for them first. And
Hmm.
then the ones that are a bit more risky, let's keep them for later. You try to go faster, do a lot of things in parallel, etc., etc. Okay, that makes sense. And then after that, in pre-production and then production ramp up, etc., try to go faster. But that's when you are sort of what we call in the delivery phases, right? The second half of the development phase, when it's like, okay, we know the product design. Product design is more or less set. We just need to define to refine a bit here, do a bit of design for manufacturing adjustments here, pop, and then work on tooling and do some reliability testing, etc., just to confirm. This is of the tail end of the product development cycle. And you just want to squeeze the team and okay, go, guys. What is slowing you down? What can we do faster, right? Of course, at that stage, you can put some pressure to go faster, and we can see it. Customers who are in this is in that part of the product development cycle are trying to squeeze us basically. Come on. How can you go faster, right?
Hmm.
That's why we say, well, maybe you need to come here also, so you can give feedback also much faster. Come here and stay for 3 weeks.
That's co-development, right?
Yes, right. You will make the right decisions on what components to pick or whatever the small design decisions. Face to face, we can go much faster. Build the prototype together, test them. You give us feedback. We see what needs to be refined, and then also in tooling, maybe build the prototype with the parts of tooling. Okay, if you're here, you can give some feedback right away. Boom, boom. Go fast. If there's a lot of details to get right for surface treatment, it needs to be whatever, anodized, plated, something. It needs to look really like that. Okay, well, be here, and then we're going to work with the suppliers that do these surface treatments, and you can see it and give feedback much faster, and the whole iterations will be much faster, right? These are some examples.
Hmm.
So accelerate the cycle time, yes, makes total sense.
Hmm.
And then finally, he says only after that automate, right?
Hmm.
So the way I understand it is you go ahead into you set up your production processes, your testing processes, etc. You go ahead in a relatively labor intensive way. You put people together to assemble the products, etc. You see how it works, you see where the issues are, and then over time you semi-automate, maybe some of the things you're going to say, okay, let's invest, let's completely automate, because there's no big questions in the air anymore. It's more about delivering. How are we going to do it? It's no longer what is it? What is the right product? What is the right process? No, we know exactly the product. We're not going back to change the product. It's been validated. We know the process. We've been running it for a while already manually, so we could adjust, right? That's the beauty of a manual process, is that you can adjust in the blink of an eye nearly in many
Hmm.
cases. When you do little fixtures and jigs and things, yeah, it takes a few days, right? Maybe it takes 1 or 2 weeks if it's a bit complicated, but in a place like China, you can get this pretty fast usually. And then once all of this is working well, you just want to ramp up and have that sort of consistent delivery of parts and products that highly automated equipment can give you, right? And also the very, very short cycle times, so that you can have a lot more capacity. At that time, it does make sense to automate. When you start to go into the high volumes, of course, you want to do that because economically it makes a lot of sense. But you should not do things the other way around, right? you automate first, and then you say, oh, actually, it's not the right product or not the right process, or then I need to scrap that. That's quite bad, right? Or you squeeze your team to go as fast as possible, but then it's actually not the right design architecture. Well, I don't know. You're gonna have a firmware engineer, keep working, keep testing, and get really, really frustrated. But actually, wait a minute, it was not even the right chip, that was selected. Oh,
Mm.
we should pick another chipset, then it would work fine. Oh, well, we just wasted, and demotivated someone for nothing. So first you ask the big questions, you set the high level architecture, etc., and you simplify and you delete parts, etc. Right? And then you're going to you really put engineers and, okay, guys, just go ahead and do it, and let's see the next prototype. Okay, test it. Okay, change this, change that. Now, okay, fast. Let's go into the next one, right? But you don't put a lot of pressure on them early on, because early on you want them actually to step back and say, well, what could happen here? What's the risk, or do we need to do a bit of research on that? Oh, is this a big technical challenge that we need to test and validate somehow? Because if this is going to be impossible, we should know about that now, not 3 months from now, right? Because it's going to take us into a totally different direction. Right? So there's really a method to it. You want people to have a certain focus, and that focus changes, in different phases. So these things that he says, obviously you cannot just take that and run and say, okay, I know how to develop a new product. That's really not helpful. However, if you have a team that's going through the development and of a new product and the transfer to manufacturing of that new product, if they have these few tips in mind, they might avoid some very big mistakes. That's the how to say, the big contribution here. I think it's quite interesting to have Elon Musk's sort of mental, how to say, rules of thumb, right? I guess these are the things that he keeps telling his teams day in and day out. So that's I think it's helpful.
And I think if you got Elon Musk to kind of draw a graph of how the new product introduction process should be, based on what he's saying, it's probably pretty similar to the one that we've produced. And that's based on our, like decades of working on this sort of thing with our customers. And even though he's using kind of quite sort of like slangy, typically Muskian words like, be less dumb in your requirements and things like that. If you look at the sort of MPI process, it does make sense what he's saying, and deleting parts or processes or simplifying and optimizing. I mean, that's DFM in a way. So
yes.
There's a lot of crossover, and that's why we bring it up. To visualize what we're talking about when we're talking about MPI process, once you've watched the video, listen to Elon Musk, you can also hit the link. I'll put it in the show notes for our MPI process graphic that we've made. It's quite detailed, but of course the MPI process is a pretty involved process that it requires a lot of different actions. So we've tried to encapsulate it in graphic form, and hopefully that's going to shed a lot of light when you're thinking about what Elon's been saying. So yeah, interesting comparison there, Renaud, and always interesting to check in what Elon Musk is saying, because although I think it's fair to say that he comes out with a lot of weird stuff, he does actually come out with some really interesting things, especially if you are developing products.
That's the point. That's what we came up with this topic to discuss today. Yeah, agree.
Great. Okay. Well, let's call it to a close now. And as ever, we will be back next week. And coming up, I'll let you know, I'll be getting Kate on the podcast, and we're going to be talking about shipping, the costs, what's driving those costs up at the moment, and also maybe a little bit about Incoterms and things like that as well. So keep your eyes on that. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.